Okay, so hello recording. We are just taking up questions from number problems. You guys feel free to ask me questions at any time. I'm just going to get started. So like I said, I'm going to first just go over every single one of these questions and tell you how I would set them up, like what the equation would be, etc. And then we'll pick one and we'll do the full solution of it. So question number 1 says the sum of the squares of two consecutive even numbers is 2,180. Find the integers. And I had told you guys last class that for these questions, you're going to have a little, the numbers are going to be slightly larger. So feel free to use your calculator. We also learned last class, if I just scroll up really quickly, that even integers means that you're going to let the first one equal to a letter like M or X or something. Then the one after that will be M plus 2, then M plus 4 plus M plus 6. So keeping that in mind, we're going to go back to our question, and I'm going to basically say the first number is going to be X, and then the second number is going to be X plus 2. That means I have two consecutive even numbers. Then, of course, you would write your let statement and all that stuff. You would say let X represent the first even number. And to set up your actual equation, you would have both of these numbers added together and squared. So it would be X squared, I always keep it in brackets, plus X plus 2 squared is equal to 2,180. And then you would do what we did last class, where you would expand it, FOIL, etc. And you would finally end up getting an answer of 2x squared plus 4x minus 2,176 is equal to 0. And you could factor out the 2 and you would get x squared plus 2x minus 1,088 is equal to 0. Now, again, like I said, these numbers are big, but if you have a calculator, you're basically trying to find two numbers that are 2 apart. So for example, you could try 20 and 22. If that doesn't work, try 24 and 26. If that doesn't work, just keep going higher and higher and play around with it until you get close to the numbers. So honestly, you could do this question without even trying to use the quadratic formula. But again, it's up to your comfort level. If you wanted to use the quadratic formula, you could. And when you do that, you end up getting, let's see what you end up getting. You end up getting 34 as one of your numbers, and you end up getting 32 as one of your numbers. In your let statement, I would write let X represent your first even number. Just because you want to make sure that everyone knows that that X has to be an even number, right? Because it's two consecutive even numbers. So I can actually put that too. So let X represent first even number. Okay, so once you've done that, you can end up solving it, and you would basically, this would give you X is equal to negative 34, and this would give you X is equal to 32. And what you've done is now you've basically solved this first number, which is for X. To get the second number, you're going to take both of your X's and you're just going to add 2 to it. So if the first number is X is equal to negative 34, if you add 2 to it, the next number is going to be negative 32. And for this scenario, if the number is 32, you add 2 to it, then it's going to be 34. So we think that the numbers are 32 and 34, or negative 32 and negative 34. At this step, you would have to go ahead and do a check. So you can use your calculator, square both of those numbers, add them, and if it equals to 2,180, and those are your answers. And I also wrote the answers up here. So, I mean, you could check there, but you should also do your own check. And then you would have a therefore statement. I guess like almost written the full solution to this. So maybe I'll just finish it off by writing therefore ... just so you guys know that you finish off with a therefore statement. Anyone have any questions? Oh, wait. Question number 2. I can't scroll that. There we go. The sum of twice a number and 3 times its square is 261. Find the number. Okay, so this is a little bit different. It doesn't have to do with consecutive numbers or consecutive even numbers. And really, you're only talking about one number. They're saying the sum of twice a number and then 3 times the square of that exact same number is 261. And now I'm remembering from previous years, this question is a little ambiguous where people, like students, sometimes get a little confused. So I should have cleared it up. You're talking about exactly the same number. So how would I write each of these things? So let's break it down a little bit. We have twice a number and then 3 times its square. So I'm just going to go to the side over here. I know twice a number is 2x. And I know 3 times its square is going to be 3x squared. And Amina got it perfectly right, 2x plus 3x squared. And then you're adding the numbers together because it's the sum. So what's that going to look like? Well, it's going to be 2x plus 3x squared is equal to 261. Why am I keeping it in brackets? I don't know, just force of habit. You don't really need to because you're not squaring the numbers or doing anything to them. But in the next step, I'll drop the brackets and I'll move everything to one side. So it's going to be 3x squared plus 2x minus 261 is equal to 0. For this question, to be very honest with you, you can't factor anything out. So I would probably actually use the quadratic formula. And you can practice doing that. So, put the numbers into A and B and C, and then practice using your calculators and seeing what you get. When you do that, and maybe some of you factored it, I don't know, it's totally up to you. But when you do that, you end up getting, what do you guys end up getting? X is equal to 9?
For question 2, when I did it, I got x equals -3 minus, and then like the square root thing, and then 2097 over 4. I got like, and like I did
Okay. When I did the quadratic formula, I ended up getting -2 plus or minus, and then the little square root sign ended up being 56 over 6. I got a whole number for one of the x's, but the other one was irrational. Yeah, that's exactly what I got, Jennifer, as well. So double check your work. It should, the number inside the square root sign actually does end up being a really nice whole number. Can you do it? Yeah, of course. So let's go ahead and just practice doing our quadratic formula for this. So our A value, this is our A, this is our B, this is our C. And so we're just going to go x is equal to -b plus or minus b squared minus 4ac over 2a. It's going to be -2 plus or minus b squared. So it's going to be 4 minus 4 times 3 times -261 all over 3 times 2, which is 6. -2 plus or minus, and then just grab your calculator and you're basically doing 4. So 4 plus 4 times 3 times 261. So I actually get 3,136.
I have a question.
Yeah.
So like, why did you put 2x, and then like when you first wrote it out in brackets, you put like 2x first and then 2x squared? But then you like in the second, like when you brought 261 over, you like switched it around. So the way I wrote it out was I left it like in 2x plus 2x squared minus 261. I left it in that order. So when I did my quadratic formula, like I think that's why I got it wrong. But how is that wrong if like, isn't that the order? Like, are you supposed to change it or something?
Yeah, you have to put it, so this order that I've put it in is called standard form, and standard form always has the x squared first. And in fact, you see your A value for your quadratic formula, it's the number that's attached to the x squared. So that's probably where you went wrong. You just didn't change up the order, and you absolutely always have to do that.
So we put it into standard form and then we put it through the quadratic formula?
Exactly.
Okay, thank you.
Yeah. So when you do this, you end up getting x is equal to 9. And then the other number will end up being like negative 9.67 or something like that. And technically both the numbers should be correct, but I remember for our class when we had done this, I just said, let's just look at the whole numbers. If you wanted to include the negative, that would be fine as well. So the numbers are 9 or negative 9.67 works as well. Perfect. All right, we're just zooming through this. Question number 3 says the sum of the squares of 3 consecutive even integers is 116. Honestly, I'm not going to do this question because this is exactly like the one that we did when we did our practice. All I'll show you is the setup. So it's just going to be x squared plus x plus 2 squared plus x plus 4 squared is equal to 116. The only difference is when we did our practice question, it wasn't even integers. This one is even, not a big deal. It's the same thing. It ends up being this very long polynomial, and then you'll reduce it to get 3x squared plus 12x minus 96 is equal to 0. You'll factor out the 3x squared plus 4x minus 32 is equal to 0. This is very easy to factor. So you'll basically just get x plus 8. Remember how I was like, oh, I'm not going to do this one. And then I basically did the whole thing. And then you end up getting x is equal to negative 8, x is equal to 4. And then you can figure out all the rest of the question, the rest of the numbers, because remember your 3 numbers that you're going to write on the side are going to be x, and then x plus 2, and then x plus 4. Okay, so hopefully that it's okay if I pause there. Are you guys okay if, with that explanation, and can do the rest? Yeah. Sure, we can, 5 can be the one we take up in like completion. Okay, great. Question number 4 is the difference between 3 times a number and its square is 378. Find the number. So again, this is one of those questions where you're only going to be looking at one number. It's just one number, not 2 of them. And let's just break down this question. So it says the difference, first of all, we should know that's a subtraction. 3 times a number, and then that same number's square is 378. So does anyone want to, you can just feel free to write in the comments what you guys got for your, when you did this. I do want to tell you one thing. Whenever you have a question that's like a difference, just remember you want to change the order. So you know how whenever you're talking about like when something is subtracted from something, we always write that second something first and then the first something. So in this question, I'm going to write this first and then I'm going to write this second. And that's kind of how you deal with any question that has subtraction or less than. So we're going to start with the number square, which is going to be x squared. And then we're going to write 3 times a number, which is going to be 3x, and it's going to be a subtraction sign. So that's basically how you would set up the question. So the difference, subtraction between 3 times a number, which is 3x, and its square, which is x squared, is 378. Find the number. Also, just recognize for questions 2 and 4, they're a little bit different where they're talking about exactly the same number. So just make sure you know what that looks like and why it's like that. Minus 378 is equal to 0. Again, simple trinomial, you could probably play around with numbers until you get two numbers that when you multiply them, you get 378, but they're 3 apart. And then Amina got it right, negative 18 and 21. So really when you factor this, you're going to get x minus 21 and x plus 18 is equal to 0. And so your numbers are x is equal to 21 and x is equal to negative 18. Good job, Sophia. Yep, that's what I got as well. And when you guys are doing these, are you using quadratic formula or are you just factoring? Like, what have you guys had more success with? Both. Okay. Factoring. Okay, good. All right. Question 5 is what we're going to do. We're going to do all of it. All right, two numbers, so we're talking about two different numbers here, differ by 7, and the sum of their squares is 289. Find the numbers. So before we even get into the math, let's see what they're actually asking us for. If two numbers differ by 7, that's like saying you have 1 and then you have 8. They're 7 apart. Or you have 10 and you have 17. They're 7 apart, right? So basically you have one number, which we're going to call x, and then the other number, I'm going to just add 7 to it. So if I were to write that down, one of my numbers would just be called x, and my second number would be either x plus 7 or x minus 7. It doesn't matter. If they differ by 7, you can either be adding 7 to the first number or subtracting 7. So if you chose x minus 7, totally fine. That's correct as well. We're going to have a let statement. So we're going to say let x represent one of the numbers. You don't need to specify if it's even or odd, because obviously this question has nothing to do with even or odd. It's just one of the numbers. So two numbers differ by 7. We already know one of them is x, the other one's x plus 7, and the sum of their squares is 389. So we're going to add them together. We're going to square it. So it's going to be x squared plus x plus 7 squared is equal to 389. I'm going to go over to the side so I can do my work for x plus 7 squared. So x plus 7 squared, this is like your rough sheet of paper or just somewhere else. That's like saying x plus 7 times x plus 7, which is x squared plus 7x plus 7x plus 49, which is x squared plus 14x plus 49. So all I've done is I've FOILed it. And I did all the messy work on the side. So when I come over here, I can just write like my final, not my final answer, but the cleaned up version. So over here, I'm going to have, oh, sorry. Okay, so I'm going to have x squared, then x plus 7 squared, we expanded over there. It's going to be x squared plus 14x plus 49 is equal to 389. The next step, I'll add up my x squareds and then I'll move the 389 over. So it's basically going to be 2x squared plus 14x plus 49 minus 389 is equal to 0. 49 minus 389 is negative 340. So it's going to be what does it keep doing then? 2x squared plus 14x minus 340 is equal to 0. I recognize that there is a greatest common factor of 2, so I'm going to take that out, and I think that'll make the question a lot nicer. So I'll just move over here. I'll factor out the 2. I'll get x squared plus 7x. That should be 170 minus 170 is equal to 0. Okay, so I don't know if you can see this. Maybe you can't see it, maybe you can. But to me, this question done by factoring is very straightforward, and I'll tell you why. I'll tell you my reasoning. I know 170 probably has a lot of factors, but one of them is definitely 17 times 10, right? That's the one that's really sticking out for me. 17 times 10 is 170. And I also know if I take 17 and 10 and if I take 17 and 10 and I add or subtract them, I can very easily get a difference of 7. So I don't need to use a quadratic formula for this question. It's actually very easy for me to just factor it, and that's what I'm going to do. So for this question, when I factor it, I'm going to get x and x, 17 and 10, and then I'm going to get plus and minus. So my factors are, my factors are 17. I'm just double checking all my work. Minus that. And so then I'm going to have negative, and then I'm going to have, yeah, that works. So now let's figure out what the rest of this is going to look like. So I know when I solve this, it's going to be x is equal to negative 17. And when I solve this, it's going to be x is equal to 10. Those are my first numbers, my x's. For my second number, I'm just going to be adding 7 to both of them. So if my first number is x is negative 17, I'm going to say negative 17 plus 7 is -10. So my second number is going to be -10. And for my second scenario, if x is equal to 10, my next number is going to be 17. So this right here is just going to be 17. So I think my numbers are either 10 and 17 or -10 and -17. But I can't be sure until I check my work. So I'm going to go to the bottom over here and I'm going to do a check. And I told you guys last class, it doesn't have to be a proper check. It could just be a quick logical check. So I'm going to take my first scenario, which is going to be 10 squared plus 17 squared. And I'll use my calculator, 100 plus 17 times 7, which is just 289. So it's just going to equal 389. Yep. And then for the next one, it doesn't matter if it's negatives, right? Because if you square anything that's negative, it's still going to equal to 389, which means both of our solutions are correct. So to finish off this question, we're going to have our therefore statement, and we're going to say, therefore, the numbers are 10 and 17 and -10 and -17. Have I included everything? Let's just do a quick check. I have a let statement. I have a therefore statement. I have a check. I have my proper algebraic solution. I have clearly written down what my numbers are. So that is like the proper solution. Okay, stop recording.